Okay, let's attempt this one. An infinite geometric series has a common ratio r, an infinite sum greater than 0. So if the infinite sum is an actual number, we know that r is between 0 and 1. And the sum of the second term r and r squared exceeds the value of the first term by 40%. So I'm assuming that means that r squared s, and I'm assuming that means that these are equal, because the sum of the oops, when adding these together, so if we take a2 plus r squared s, it's equal to 7 over 5. Yes, 7 over 5 a1. S is an integer and only the first two terms of the series are integers. Find the least possible value of s. Okay. So we can change this to r a1 plus r squared s equals 7 over 5 a1. Then just move everything to one side. Oh, this is a quadratic. R squared s plus r a1 minus 7 over 5 a1 equals 0. Then we could say r is equal to negative a1 plus or minus the square root of a1 squared minus 4 s 28s 28 over 5s all over 2s. I'm going to change it to this s because I will not mistake that with a 5. So, okay. All we know that s is an integer, and the first two things of the series are integers. So, but the ratio definitely is not. And we know 2s is greater than all of this, right? Yeah. Okay, let's look at this. So, we need this to be a square number. And if this is a square number, (28 over 5s) equals a square number. So we know s has to be divisible by 5. S is divisible by 5. So let's just say s is 5. Is there any two square numbers when subtracted from each other that equal 28? Let's see. So let's just take like 144 minus 121 is 13. Let's see. 144 minus 100. I know that this will always be odd. Just remember this. If two consecutive ones. So let's go further down. So, and we'll take the difference of 2. So let's go 121 minus 81 equals 0, 12, 0, 4, 40. 40 is still too big, so it seems like we decrease, wait, let's write this out. If we have n squared, n plus 2 squared minus n squared is equal to 0, is equal to 0. What? No, let's just simplify this. N squared minus 4n plus 4 minus n squared. So it's just 4n plus 4. Does that make any sense? 100 is 4n plus 4. 8 is, yeah, okay, that makes sense. 4n plus 4. So what was I trying to do? I was trying to get the difference. So 28 is equal to 4n plus 4. So that means 24 is equal to 4n. So 6 is equal to n. So 6 is the lower, so it's 64 minus, 36. And then 14, 5, 8, 2, 28. Okay, so this is 28. So if we say S is equal to 36 and A1 is equal to 8, then we get, oh, what do we get? We get, oh, but S isn't, that's not divisible by 5. That's an issue, that is an issue, that's an issue, that's an issue. Oh, that's not what I was supposed to do. That means this is equal to 64, this is equal to 36, and S is equal to 5. So A1 is equal to, whoa, A1 is equal to 8, S is equal to 5. I don't know if S can be less than A1, depends on what R is. 5, and so this entire thing is equal to 36, right? Let's just check that out. So it'd be 64. Let's double check. 28, 14, 5, um, um, uh, 6, right? Yeah, 6, 3, 36. Yeah. So then that's negative 8 plus or minus the square, plus or minus the square root of 36, which is 6, over 2 times S, and so it's 10. So that's equal to negative 8 plus or minus, negative 8 plus 6 over 8 is equal to over 10. Okay. So while I was doing this, so that gives us R. Now, I just remembered we could get the formula for S over 1 minus R. So S is equal to, let's just say, so does this match up? So 5 is equal to 8 over 1 minus, oh, 1 over 5. So 5 is equal to 8 over 6 over 5. No. And negative 7 over 5 won't work either. So let's just turn this into a system of equations with something here. So what do we want to get the both in terms of? We want to find the value of S, so why don't we get it in terms of, why don't we just get it in terms of R, because we already have it in terms of R down there. So then we have S times 1 minus R is equal to A1. S minus SR is equal to A1. No. 1 minus R is equal to A1 over S. So 1 minus A1 over S is equal to R. So 1 minus A1 over S is equal to negative A1 plus or minus the square root of A1 squared minus 28 over 5 S all over 2S. Okay. So, let's multiply both sides by S. So now we have S minus A1 equals 1/2. We'll multiply both sides by 2 too. So 2S minus 2A1. Okay. Okay. Now, can we square both sides or something to get rid of this plus or minus? Because I really don't like that plus or minus being here. Would that work, to square both sides? I think it would. So, let's just write it as 2S minus A1 squared is equal to A1 squared minus 28 over 5S. So then we have 4S minus 4S squared minus 4S A1 plus A1 squared is equal to A1 squared minus 28 over 5S. Could subtract both these. You can divide by S on both sides. So we have 4S minus 4A1 is equal to negative 28 over 5. So then, let's just get this all on one side. 4S minus 4A1 plus 28 over 5 is equal to 0. How does this make any sense? Because we know both S and A1 are integers. So how, subtracting them, you can't get a fraction. Let's see, did I mess anything up? This is 2S. Add A1 on both sides. Square it. Square both sides. 4S squared minus, plus A1 minus 4AC. Pi. Normal. Good. Um, oh, I see the issue. This is A1. As A1 here, A1 here, A1 here, A1 here, A1 here, A1. So, 4s minus A1 times plus A1 times 28 over 5 minus 4 is equal to 0. What's 28? It'd just be 8 over 5. So back here, 4s plus 8 over 5 A1 is equal to 0. Okay. We can divide both these back too. So s plus 2 over 5 A1 equals 0. Okay. Let's find a spot where I can work. Here. So we have s plus 2 over 5 A1 equals 0. So, what do we know? Our only constraints now, since we've succeeded these two, since we solved a system of equations, are that these are integers. So s is positive, A1 must be negative, of course. So s is equal to 2 over 5, negative 2 over 5 A1. Okay. Now we just need to make sure the second term is an integer. So we must make sure that A2 is an integer. So if we just say A1 is equal to negative 5, so s is equal to 2, then let's solve for r. 1 minus 1 plus 5 over 2 equals r. No, then A1 can't be negative, because r is... Since r is positive, does r have to be positive? R can't be... r can't be greater than 1. We know that. Because, yeah. And r can't... Can r be negative? Yeah, r can be negative. So, but if we make this term positive, that makes it greater than 1, and that's impossible. So then A1 can't be negative, but A1 has to be negative. Okay, I don't know what I did wrong. I'm gonna check it, sir. Because I don't know what I did wrong. this was the third problem, and third problems are usually good, so it was 144. If a is the first term, then we set up the equation, which I did set up. They said noting that s equals a over 1 minus r, we can eliminate a from the equation by I don't really know what they did there. And then they got a quadratic, I believe. No, they didn't. And they just like simplified it somehow. And then they found r, and then plugged r into a over 1 minus r. And then they found if s must be an integer, a must be divisible by 5. I did know a must be divisible by 5. And only the first two integers. Then the first term is divisible by 12 because the first term, because r is 7 over 12. Therefore, the least possible a is 60, making the least possible value of s 12 over 5 times 60 equals 644. Okay, I don't really know what I did wrong, but I'll leave that up to you guys. Thank you guys for watching. I will see you guys in tomorrow's video. Yeah, goodbye.